Hello and welcome to lesson 1-6. Today we're going to look at what we call measures of central tendency, or the mean, median, mode, and range. So let's begin by taking a quick second to review what the different terms mean. Now keep in mind that mean is also known as our average. This is used to describe the middle set of data, okay, so it's a middle set of the data type of number, but it does not have outliers. Outliers can have a big impact on the mean, okay? And a good way to think about this is if you have a classroom set of, let's say, 20 students, okay, and you guys all kind of have a class average around an 80, and you have 2 students that do not take a test and they have a 0, those zeros would be considered outliers. And an outlier just means that it's a data value that is either much higher or much lower. It's kind of like it doesn't belong with those values. Okay, so those 2 zeros are going to really bring down that median or that mean. Okay, the way we calculate the mean is to take the sum of the data items and we're going to divide it by the total number of items. So this right here is a really important formula that you need to know. The median is the middle number when the data set is arranged from least to greatest. Okay, now the thing you want to keep in mind with the median is this is when we want to use our outliers. Okay, and then the last thing we're going to look at is what we call the mode, and the mode is the item that occurs the most frequently. Okay, now the one thing I want you to remember is sometimes there is no mode because your data only occurs like once, and if everything only occurs once, then you have no mode. Likewise, though, you may also have more than one mode. So example 1 wants us to find the measures of central tendency and the range. We'll talk about the range here in a minute. So what I like to do is I always like to start out by arranging my data in order from least to greatest. So if I do that, I have 9, 10, 10, 12, and 15. Okay, then I'm going to go and I'm going to find the mean. So for the mean, I'm going to add up those numbers. So I have 9 plus 10 plus 10 plus 12 plus 15. So that's the sum of all my numbers. Then I'm going to divide it by the total number of numbers that I have here. So I've got 1, 2, 3, 4, 5. So I'm going to divide that by 5. And when I do that, I get an answer of 11.2. So this here is our mean. Now to do the median, so the median, remember, is a middle number. So I've got 1, 2, 3, 4, 5 terms. So the median is actually easy to calculate it because it's literally the middle number. Now, if you have an even set of numbers, then you would have taken the average of the 2 middle numbers, and we'll do an example later on with that. So our median, though, in this case, is actually the number 10. And finally, our mode is the number that occurs the most. So when I look at my set of data, I can see that I have the number 10 that occurs twice, and that's the only number that repeats itself. So my mode then would also be 10. Okay, and then last but not least, we have our range. Now our range is nothing more than our largest number, which is 15, minus our smaller number, which is 9. So our range is 6. And what the range does is the range just kind of tells you that all your data points fall within kind of like a 6-point spread. Please take a quick second and try example 2 on your own. When you're finished, hit the play button and we'll continue on. So again, I'm going to suggest that you rearrange your numbers in order from least to greatest. So here I can say I have 2, 3, 10, 11, 12, 13, 14, and 16. So when I go to find my mean, I'm going to add these up. So I have 2 plus 3 plus 10 plus 11 plus 12 plus 13 plus 14 plus 16. And then I'm going to divide that by 1, 2, 3, 4, 5, 6, 7, 8 numbers. So I'll go ahead and divide that by 8. When you add the numerator and divide by 8, I got 10.125 for my mean or average. Then our median, remember your median is like that, the middle number. So we have 8 terms. So I have 1, 2, 3, 4. So because I have 8 terms, I really have 2 middle numbers. So I have to average the 2 middle numbers. So I'm going to go 11 plus 12 divided by 2 because I have 2 terms. And this is going to give me 11.5 for a median. And then I'm going to look at my mode, which in this case, I do not have a number that repeats. So you can write none, or I know some of you like to write the empty set, and that's fine. And then we're going to end with finding our range. Now keep in mind, the range is your largest number, which is 16, minus your smallest number, which is 2, and this tells me I have a range of 14. Now example 3 may look a little different, but it's really the same concept. Here we have to find the mean, the median, and the mode of the data in the line plot below. Then we have to tell which measure of central tendency best describes the data. Okay, so essentially what I'm going to do is I'm going to start out by listing my data in order from smallest to largest. And when I look at this right here, I can see that I have 1, 2, 3, 4, 5 occurrences. So I have 6.25, 6.25, 6.25, 6.25. So it's 1, 2, 3, 4, and another 6.25. Then I'm going to have 3 650s. So 1, 2, 3. I have 1 7, and I have 1 8.25 down here. So for our average, you are going to add all of those up. So our average or mean is going to be, I ended up with 6.60 when I calculated this. Then I had a median. Remember, median is your middle number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So 1, 2, 3, 4, 5. So I am going to take and add the 6.25 to the 6.5 and divide by 2. And my median then is going to be 6.375. And keep in mind these are dollars, and I should keep that with it. And my mode is the number that occurs the most. Well, the nice thing about a line plot is I really do not have to look at my numerical data, like right down here. I can go directly to my line plot and see that the 6.25 occurs the most. So the mode is $6.25. So here's our measures of central tendency. Then the second part says, which is the best measure of central tendency to describe this data? And I would say, because you do have a number out here that kind of doesn't fit in with the rest, and some may even argue that 7 kind of doesn't fit in with the rest, these are what you would call an outlier. So because we do have outliers, the median is going to be the best representation of this data. Okay, and you can even see that on your graph, because you can see that you have a big chunk of your data down here, and then you just have 2 points kind of off by themselves. In the previous example, we looked at a line plot. Here, we have what we call a stem and leaf plot. Now, with a stem and leaf plot, we have a couple key pieces. Okay, so first of all, you're going to have the vertical axis here. This is called our stem. And notice it's kind of set up in a table format. You're going to have a line here, a horizontal line, and a vertical line. And your stem is going to be separated from what we call the leaves. So the leaves then is going to be all of like the data points out here. So you have your stem and your leaves. Now, with your stem and leaf plot, typically you have a key, and that key is going to tell you, and again, the key is like right here. The key is going to be, it's just going to tell you kind of what the numbers are. So it says 2, and then the bar, and then the 5 really means 25. So if I were to look at this number here, this 2, and this 5, that tells me I have the number 25. And that's actually how you read a stem and leaf plot. And this is nothing more than another way to kind of display a bunch of data points. So to create a stem and leaf plot, we are going to take our data points. Okay, again, I like to list them from smallest to largest, and by looking at this set of data here, that's already been done for us. And we can create our stem and a place for all of our leaves. So for my stem, I'm going to look at, it looks like I have 3 tens, 4 tens, 5 tens, 7 tens. So if I'm gonna make my stem, and the stem, remember, is this portion here. So I have 0 tens, 1 10, 2, 3, 4, 5, 6, 7. Now, I don't need to go beyond that, so because I'm running out of room, I am going to stop. Then my leaves, I'm going to go ahead and put those in. So for the number 33, I have 3 tens and 3 ones. Then I have 36, which is 3 tens and 6 ones. Then we're going to jump up to 42, so that's 4 tens, 2 ones. I have 2 number 45s. Then we have a 50, so that's going to be 5 tens and 0 ones. We have 51 and 57. Then I have no tens of 6, but then I'm going to have 7 tens with 0 ones, and then I'm going to have I have 72, which would be 7 tens and 2 ones. So this right here is another way, and if you wanted to put your key, you could do something like this, where you do, and you could just pick a number, like maybe you want to do 3 and then 6 equals 36. So essentially what that does is it tells you that the number on the left is the tens, the number on the right is the ones. And this is how you create a stem and leaf plot. For our last example, we kind of have a stem and leaf plot that has 2 in 1 plot. Okay, and what I mean by that is if you look at, we have our stem is this set of data down the center, but we have leaves branching off in either direction. You have your highway leaves, which are over here, and then we have our city leaves, which are over on this side. And you can see down here that we have a key that says if I have a number before my stem, that it's really, like in this case, 02 means 20 miles per gallon. And over here underneath the highway side, if I have my stem and then my number, that really means we have 27 miles per gallon. So we are going to find the city mileage, or the average for the city mileage and the average for the highway mileage. So to show our work, we'll start out with a city. So for city, I am going to take, and it looks like I have 19 plus 20 plus 23. And so here's my 19, here's my 20. I have two 23s. and I get that from here and here. Then I have 28 plus 29. That gets me these two. Then I'm going to go down to 31 plus 31 plus 34. And then I'm going to divide that by the total number of data points. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. When I do that, when I add the top and I divide by the bottom, I actually end up with 26.4 miles per gallon. And again, that's with the city. So I can go ahead and do the same thing then for the highway. So here I have, it looks like we have 27 plus 28. And again, I'm getting that from this 27, that's 28, plus 30, plus 32, plus 32, plus 37, plus 38, plus 38, plus 41. We're going to divide all of this by our total number of data points. So when I count those, we have, looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. So I divide this by 9. And I see that we end up with a highway average of 33.6 miles per gallon. And this is going to conclude the 1.6 Part 1 video.